Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Al-Haris bin Absalam. My metric number is B0717102028. I am student from University Technical Melaka. Today I'm going to present about investigation of heat dissipation via passive cooling technique on solar panel. My supervisor is Encik Zahasra bin Zakaria. This is my project poster and I will explain about my project poster in this presentation. First, introduction. Renewable energy have become the alternative clean energy that have been used in Malaysia. One of the renewable energy that have become increasingly used in Malaysia is solar. The weather in Malaysia make a solar as a perfect choice to use as a renewable energy, but need to use a cooling system for solar to get the maximum efficiency. And then I will explain about problem statement. The average temperature in Malaysia is 34 Celsius and the ideal temperature for PV panel is 25 Celsius. The efficiency of PV panel will decrease when the temperature increase. Too much absorbed radiation can reduce the maximum output of PV panel. Next, I will explain about objective. To improve the efficiency of solar panel by using passive cooling technique, and then to monitor the temperature on PV panel during sunny days. Next, I will explain for methodology. Study the problem statement and the effectiveness of heatsink as a new cooling system method, and then develop the cooling system for PV panel using a heatsink. Next is design and construct the heatsink design to apply on PV panel, and then collect data measurement according to the output parameter. Lastly, analyze. This is result without heatsink. This is the graph between voltage and the temperature without heatsink. The highest value is 60.75 volt when the temperature achieve 50.2 Celsius. Even the highest temperature at the panel was 75.5 Celsius, but voltage value was 60.43 voltage, and that was not the highest value for voltage. For the current against temperature, the highest value for current was 0.24 when the temperature value was 54.8. Even the highest value temperature was 57.5, but the current value only achieved 0.23 ampere at 12 p.m. Next is the result with silicon. Next, I will explain for result with silicon. For voltage against temperature, the graph showed that the highest value for voltage was 17.5 volt when the temperature value was 52.2 Celsius at 1 p.m. For the current against temperature, the graph showed that the highest current value is 0.25 ampere when the temperature on the panel achieved 52.2 Celsius. Even it's not the highest temperature on the panel, but it still can reach the highest value of the current. And then I will explain for result with aluminium heatsink. For the voltage against temperature, the graph showed that the highest value for voltage was 80.1 volt when the temperature value was 50.2 Celsius at 1 p.m. For current against temperature, the graph showed that the highest current value is 0.26 ampere when the temperature on the panel achieved 50.2 Celsius. And then I will explain about comparison temperature. Comparison temperature is made between panel aluminium heatsink, silicon heatsink, and without heatsink. The graph showed that the aluminium heatsink cooling system for PV panel is much cooler than without cooling system and silicon cooling system for PV panel. It can be concluded that aluminium heatsink cooling system can reduce better temperature compared with other. For project features, I'm using a aluminium heatsink and a silicon as a passive cooling technique. I'm installed all this material behind the solar panel. Next is project inventiveness. For project inventiveness, I'm using an Arduino system and sensor DS18B2 to measure the temperature. I'm connect with an Arduino system in computer to measure the temperature. And then I will explain about potential and commercial. Expectation for this project is to help consumer to get a maximum power from their PV panel. Next is to develop a solar industry by using this cooling technique to gain more power from solar radiation. For conclusion, we can conclude that PV panel with aluminum heatsink has higher efficiency and silicon heatsink has less efficiency compared to aluminum heatsink. PV panel without any heatsink has made PV panel efficiency decrease. It is set up how I measure all the parameter like voltage, current and temperature. It is PV panel with aluminum heatsink, and this is the output where the supply, and this is the Arduino. As the load, I'm using an indicator for measure the current, and to measure the voltage, I'm using this sensor, and this sensor is connect with Arduino, and this Arduino software. This is how I measure the voltage. First, I must measure the temperature. The temperature is around 41.1. Then I must measure the voltage. The voltage is around 17.9. This is how I measure the current. First, I need to connect the load in series with the multimeter and the PV panel. And then I must read the temperature. The current is around 0.2 amp.